we will be graphing linear functions in slope-intercept form. And just as the name tells us, we're going to look at slope and y-intercept. So here's an example of a linear function graph on a coordinate plane. Notice the y-intercept, where the line crosses the y-axis, is at 2 in this particular example. And just as a review, we could also look at the x-intercept, which appears to be located at -1. So a quick review, x and y intercepts, where the line crosses the x and y axis. Another thing we can look at on this graph that we've already learned is the slope. Slope is the ratio of the rise to run. And it looks like we rise 4, run 2, or maybe rise 2, run 1. This would be a positive slope. We're going to use two pieces of information to write our equations. We're going to use the slope of the line and the y-intercept. We've already seen that graphing linear equations with two variables requires us to plot x and y pairs. When we plot the x and y pairs that make the equation true, we have graphed a line. So in this section, instead of making a table and plugging in and solving input and output, we're going to use slope-intercept form. So follow along with me as I label the equation. Y equals mx plus b. The dependent variable is your y. The independent variable is your x. Again, remember, a dependent variable is your output and the independent variable is your input. B is the y-intercept and m is the slope. So what we'll do in this section is you will write an equation in slope-intercept form. You'll plug in a number for m, you'll plug in a number for b, and then we'll also look at equations and we'll pull out the information, the slope and the y-intercept. So these four equations are written in slope-intercept form. Y equals mx plus b. Let's see if we can label the slope and the y-intercept. So in our first equation, y equals 2x plus 1, we're thinking of the equation form, y equals mx plus b. The number in front of x is your slope. The number at the end, the constant that you're adding, is the y-intercept. So our slope is 2, and our y-intercept is positive 1. Example 2, there's an understood 1 in front of x, so our slope is negative 1x. And then our y-intercept is negative 4. Y equals mx plus b. Y equals negative 1x plus negative 4. Number 3, what's your slope? Right in front of x, 1.5, or 1.5. And the y-intercept is the constant at the end, which is 3. And finally, number 4. Your slope, your rise over run, your m, 2/3. And your y-intercept is negative 1. So y equals mx plus b, picking out the slope and the y-intercept when the equation is solved for y. When you want to graph an equation in slope-intercept form, there's two things you need to do. First of all, you plot the y-intercept on the coordinate plane, and then you use the slope, the rise over run, to find more points on the line. So we're going to go back to our same examples. Number 1, y equals 2x plus 1. The y-intercept is 1. So we're going to put a dot on the y-axis at 1. That is a point, 0, 1. We're now going to use the slope to rise 2 and run 1. How many points do you need to graph a line? Well, you only need 2 points. However, let's keep using our slope, rise over run, to find more points on the line. So I rise 2, run 1. Now I'm out of space at the top in my first quadrant, so what I'm going to do is I'm going to go back to my y-intercept, and the same thing, instead of rising 2 over 1, I'm going to drop 2 and run to the left 1 because a negative 2 divided by a negative 1 is a positive 2. So I'm just changing directions. I'm going to drop 2, run 1. Drop 2, run 1. Drop 2, run 1. And then you'll take a line or straight edge or ruler, and you're going to draw a line to connect your points. So using slope-intercept form, y equals mx plus b, we started with the y-intercept and then used the slope. For example 2, we'll start off at the y-intercept, which is at negative 4. So on the y-axis, we're going to put a point at 0, negative 4. That's our starting point. From there, we will use the slope to find more points. The slope is negative 1. So we can think of that as meaning drop 1 and run 1. Drop 1 and run 1. Drop 1 and run 1. The slope is negative. Going back to the y-intercept, I can rise 1 and run left 1. Rise 1, run left 1. And you can keep doing this until you fill in the entire coordinate grid with your line. Again, you can use a straight edge to connect all your points so that you've graphed a linear equation. Number 3, where do we start? At positive 3, the y-intercept, 0, 3. Now this time, 1.5, how do you rise 1 and a half and run 1? Well, we can convert 1.5 to a mixed number, 1 and a half. Still a little confusing, so let's make that an improper fraction, which would be 3 over 2. So now we'll rise 3 and run 2. That's the slope of 1.5 or 1 and a half. Rise 3, run 2. I'm out of space at the top, so I'm going to go backwards. I'm going to drop 3 and run to the left 2 because a negative 3 and a negative 2 make a positive 1.5. Drop 3, run 2. And using a straight edge, you're going to draw your line by connecting all of your points. And remember to put little arrows at the end because we are graphing lines, not segments. And our last example, number 4. We're going to put a dot at the y-intercept, our point 0, negative 1. And just thinking about the slope, it's positive, so my line should be increasing from left to right. Because I'm going to rise 2, run 3. Rise 2, run 3. Or work backwards, drop 2, run to the left 3. Drop 2, run to the left 3. And finally, we'll connect our points, and we've graphed a linear function. In slope-intercept form, y equals mx plus b. So what if I give you the slope and the y-intercept? Can you write an equation in slope-intercept form? Again, this is y equals. I'm going to sneak down here to the bottom of my page, and I'm going to type in y equals 8x plus negative 3. Or remember, I don't like double signs, so instead of writing plus negative 3, I'll just write minus 3. Number 6, y equals, it's mx, so m is negative 2, negative 2x plus negative 1, or y equals negative 2x minus 1, if you only want to use one sign. And number 7, y equals negative 1x minus 7. Now on a standardized test, we're not going to write the negative 1 as a coefficient, just like we wouldn't write 1x with 1 as a coefficient. So a better way to write that would be just y equals negative x minus 7. And the next thing we're going to do is we're actually going to look at a graph and take the information from the graph to write our equations in slope-intercept form. So let's think about the information we need for slope-intercept form. We need the slope, we need the y-intercept. Now on these three graphs, I do have the y-intercept labeled. So what we're going to need to do is we're going to need to find the slope. Rise over run. Rise 2, run 1. Y equals 2 over 1x minus 2, the y-intercept. Or a better way to write that is y equals 2x minus 2. 2 over 1 will simplify to 2. Number 9 is a negative slope. So our number in front of x should be negative. Rise over run. Y equals negative 3 over 3x plus 3. And negative 3 over 3 will reduce to negative 1. Y equals negative 1x plus 3. Finally, in number 10, another positive slope. So our number in front of x should be a positive number. Y equals rise over run. Y equals 3 over 4x minus 5. And 3 over 4 does not reduce, so we'll leave 3/4 as our slope. Thank you guys for listening to this lesson. Now let's do some work together.